Welcome back to the Deep Dive. Today we're going to be looking at deep learning.
Oh, yeah.
It's a hot topic everyone's talking about, and we got a great source for this deep dive.
Oh, yeah. What is it?
Well, it's this book all about it, written by François Chaulay.
Okay.
But here's the thing,
Yeah.
it's in Chinese. The title is Python U.
Wow. Okay. So that's deep learning with Python then.
Exactly.
That's quite a challenge for a deep dive.
Well, don't worry.
Yeah.
We've got you covered. We went through it all, and we're going to break down all the cool stuff from the book for you.
Huh.
No Chinese required.
Sounds good.
So
Yeah.
I think a good place to start is with the Keras framework.
Oh, definitely. This book uses Keras, which is a really popular tool for building deep learning models. So it's a great choice for our deep dive because we're going to be able to see how these concepts are applied in a practical way.
I think so, too. And that actually brings us to a good starting point.
Okay.
Like, what exactly is deep learning? Because I feel like, I hear it everywhere,
Yeah.
but I still kind of feel like it's science fiction.
I get that. It does sound kind of futuristic, right? But it's actually very logical when you break it down.
Okay.
So deep learning is a type of machine learning,
Okay.
which is itself a part of this bigger idea of artificial intelligence.
Oh, okay. See.
And the book actually brings up this question that Alan Turing asked a long time ago.
Okay.
Can machines learn?
Hmm.
And deep learning is basically trying to answer that question. Like, how can we make machines learn like we do?
Okay. So instead of like programming all the rules,
Right.
it's more like giving the computer a ton of examples and then it can figure it out.
Exactly. The book gives a really great example of a system learning to tag your vacation photos.
Oh, okay.
So think about it. You feed it all these pictures that are already labeled as beach, mountains, city, and the system starts to recognize those patterns in the images,
Oh,
the
wow.
things that make a beach different from a mountain,
Okay.
and then it can start tagging new photos all on its own.
That is amazing. So
Yeah.
no more spending hours tagging every single photo from my trip. I love that. This feels way more advanced than like those older machine learning things I've heard about.
It's definitely a big step forward. You're right. We're past things like, probabilistic modeling or even some of those early neural networks.
Right, right.
And what's really cool is deep learning can actually automate something called feature engineering.
Okay.
Yeah.
Feature engineering, what's that?
So basically, it's like figuring out what parts of the data are really important for the machine to pay attention to.
Okay.
It's like before we had to tell the model, hey, look for pointy shapes if it's a mountain or look for blue stuff if it's an ocean. But now deep learning models can figure out those key features all by themselves.
Wow, okay. So these deep learning models are learning, but how? What's happening inside? I mean, are we talking robot brains here?
Haha. Not quite robot brains, but we are talking about neural networks.
Huh?
These networks are made up of all these different layers, and each layer does its own little mathematical transformation on the data. So you can almost picture it like the data is flowing through this network like water going through a series of filters, and at each step it's getting tweaked and refined a little bit more.
Okay, so that data that's flowing through, what are those things called?
Tensor.
Tensors, yes. They always sound so intimidating.
I know, right? It sounds like something out of like physics or something.
Yeah, yeah.
But it's not really that complicated. Think about it like a spreadsheet. But it can have more than just rows and columns. It can have as many dimensions as you need, like a multi-dimensional spreadsheet.
Oh, okay, that makes sense.
Yeah. So you've got these tensors flowing through the network. They're constantly being, manipulated and transformed. And the network actually learns by adjusting its internal settings, what we call weights, to get better and better at predicting the right answers. And this process is called gradient descent. It's like the model is making these educated guesses, seeing how far off it is, and then tweaking its approach based on that feedback.
So it's like the network is a student practicing and getting better over time.
Exactly.
But what I find really mind-blowing is that these networks can find patterns that, like, even we might not be aware of.
Absolutely. That's where that deep learning really comes into play.
Okay.
Because these networks can create these incredibly complex representations of the data. They can find these subtle connections and relationships that, we would never be able to spot just by looking at it ourselves.
So we have these neural networks that can learn these really complex patterns. But how is this all used in the real world? What are some of the things that deep learning can do?
Well, let's start with something that's easy to picture. Computer vision. Deep learning has completely changed how computers see and understand images.
Okay.
And the key player here is something called a convolutional neural network, or a CNN.
Oh, CNNs. I've heard of those.
Yeah.
But how do they actually see? I mean, do they have tiny digital eyes or something?
Haha, not quite eyes, but they do have these things called filters.
Okay.
And these filters scan across the image looking for clues.
Okay.
So the early layers might detect really basic features like edges or lines,
Mhm.
while later layers start putting those pieces together to recognize more complex shapes and even whole objects.
So it's kind of like the network is building an understanding of the image,
Yeah.
like starting from the simple blocks
Uh-huh.
and then building up to the bigger picture. Kind of like how our own brains work.
Exactly. That's a great analogy. And there are a bunch of, clever techniques built into CNNs, things like padding, stride, and max pooling.
Oh, right, right.
And these things help control how information flows through the network and makes it way more efficient.
And what about data augmentation? I remember reading about that in the book.
Oh yeah, data augmentation is a great way to make your model more robust. Think of it like this. You're giving the model extra practice problems,
Mm.
but with a few variations. So for
Yeah.
images, you might flip them, rotate them, zoom in a bit, adjust the colors, things like that.
Oh, sure.
And this helps the model generalize better, so it doesn't just memorize the specific examples it was trained on.
So it's like that student who just crams for the test and then forgets everything the next day.
Exactly. You want your model to really understand the concepts
Yeah.
and not just the specific examples. And this is especially useful when you don't have a ton of data to work with.
That makes a lot of sense.
Yeah.
The book also mentions something called transfer learning.
Oh, right. Transfer learning is super powerful. Basically, you're taking a CNN that's already been trained on like a massive data set, like millions of images,
Wow.
and you're using that as a starting point for your own task. So you're not starting from scratch. You're
Right.
taking advantage of all that previous training.
That's so efficient.
Exactly. It saves you tons of time and computing power because you just fine-tune that pre-trained model to fit your specific needs.
And what I find so fascinating is that you can actually visualize what these CNNs are learning.
It's really amazing. It's like you're getting a glimpse inside the mind of the machine, seeing how it's interpreting the world.
Yeah, we've covered a lot of ground with these CNNs and image processing.
We have, but we've only scratched the surface of what deep learning can do.
I know. There's so much more to explore.
There is a whole other universe of applications.
Well, hold on to your hats, everyone, because when we come back, we'll be venturing beyond images into the world of text and language processing. And deep learning is changing things up there, too, so you won't want to miss it. Welcome back to the Deep Dive. Last time we were talking about all these amazing things that convolutional neural networks are doing in computer vision.
Yeah, they really are changing how computers see.
It's wild. But I know deep learning goes way beyond just images, right?
Oh, absolutely. It's making huge waves in natural language processing, too, which is all about how computers understand and work with language.
That seems so much more complex to me. Like, how do you even start teaching a machine about language?
It is incredibly complex because language is so nuanced, right? But that's what makes it such a fascinating challenge for deep learning. And one of the key breakthroughs here is something called word embeddings.
Word embeddings. Okay. I'm trying to picture what that even looks like.
So imagine if you could represent each word as like a point in space.
Hmm.
And words that have similar meanings, they would be closer together. So happy and joyful would be neighbors, but happy and sad would be way far apart.
Oh, okay. So it's like a map of language where the distance between the words shows you how closely they're related in meaning.
Exactly. And what's really cool is that the model learns this map all by itself. It figures out these relationships just by analyzing tons and tons of text and seeing how words are used in context.
Wow. So it's like the model is reading a dictionary, but then going way beyond the definitions to understand all the subtle ways that words connect to each other.
Exactly. And just like with CNNs, we can take advantage of pre-trained word embeddings. Oh, right, right. So instead of having to train our own from scratch, which takes a lot of data and computing power, we can use these embeddings that have already been trained on these massive data sets. One example is GLOVE, which stands for Global Vectors, for word representation.
Glove. It's like having access to this global map of language that's already all laid out for you.
Exactly. You don't have to reinvent the wheel. You can just plug these pre-trained embeddings into your model and get started right away.
That's amazing. But okay, so we have these word embeddings that capture meaning, but language is more than just individual words, right? It's about sentences, paragraphs, how words flow together. How do we deal with that?
That's the next level of complexity. Images are kind of static, but language flows over time. And to capture that, we need a different kind of neural network.
Yeah.
And that's where recurrent neural networks, or RNNs, come into play.
RNNs. Okay.
Unlike those feed-forward networks we talked about before, RNNs have the special ability to remember information from previous steps in the sequence.
So as the network is processing a sentence, it's not just looking at each word in isolation, it's remembering the words that came before it, like it has a memory of the conversation.
Exactly, and that's what makes RNNs so powerful for natural language processing. They can learn these patterns and dependencies over time, which is crucial for understanding language.
So for things like language translation or sentiment analysis, where the meaning depends on the whole context, not just individual words, RNNs would be the way to go.
Absolutely. And there's a ton of research happening right now into different types of RNN architectures and all these advanced techniques to make them even better.
It sounds like there's so much happening in this field. Where do you see all this research heading? What are some of the exciting frontiers that scientists are really buzzing about?
Oh, there are so many. One area that's really taking off is generative models.
Generative models.
So these are models that can actually create new content, like realistic images, compelling text, even music. We're talking about machines becoming more creative.
Whoa, that's wild. Like machines that can write stories or compose music.
Yeah, it raises all sorts of interesting questions about the nature of creativity, doesn't it?
It does. And the possibilities are like mind-boggling. Imagine personalized content, custom-made stories, or images that are generated on demand.
Exactly. And it goes beyond just creativity. The book also talked about something called meta-learning, where models can actually learn to learn.
Learn to learn. What does that even mean?
So these meta-learning models, they can adapt to new tasks super quickly, even with just a little bit of data, because they figured out how to learn.
So they're not just good at one specific thing. They can learn how to learn new things.
Exactly. It's like giving them the ability to generalize their knowledge
Wow.
and apply it to brand new situations.
That could be incredibly powerful.
Whoa, it is. And it leads to this other exciting area, automated machine learning, or AutoML.
AutoML.
It's where algorithms are actually designing and optimizing other models.
So it's like taking the human out of the loop.
Kind of, yeah. The machines are figuring out the best way to build and train themselves. AutoML could make AI way more accessible to more people and really speed up the pace of innovation.
But doesn't that also raise some questions about, control?
Yeah.
And what about human expertise in a world where machines are designing themselves?
Oh, for sure. There are a lot of ethical and philosophical questions that come along with all this progress. It's something we need to be thinking about carefully as we move forward.
We've come a long way from talking about tagging vacation photos to, machines potentially designing themselves.
We have. Deep learning is a powerful force.
It really is. Well, folks, get ready because we're about to wrap up our deep dive into deep learning. Stay tuned for some final thoughts and key takeaways and maybe even some inspiration to start your own deep learning journey. Welcome back to the deep dive. We've explored so much in the world of deep learning, from the inner workings of neural networks to those amazing applications in computer vision and NLP.
It's been a whirlwind tour for sure.
It really has.
Yeah.
But before we go, I think it'd be great to take a minute and, recap everything.
Yeah, definitely. Let's distill some of the key takeaways from our deep dive.
Perfect. So for you, what really stands out from all of this?
You know, what strikes me the most is just the raw power and flexibility of deep learning. Like, these models can do things that were just unthinkable a few years ago.
Totally. We've seen how they can handle super complex tasks, whether it's recognizing faces or translating languages, with amazing accuracy.
It really is a game changer for AI.
It is. But the book also stressed that it's important to go beyond just the results,
Oh, absolutely. It's not enough to just treat it like a magic black box. If we want to really harness the power of deep learning, we need to understand how it works.
Right, right.
So that means understanding things like how data is represented as tensors, how those layers in a neural network process information, the whole process of learning through gradient descent.
And all those techniques that we talked about, like data augmentation, transfer learning.
Yeah. Those are essential tools in the deep learning toolkit.
They are. So for our listeners who are feeling inspired to dive deeper into this world, what would you recommend? Where should they go from here?
Well, the book itself is a great starting point. Even if you don't read Chinese, the concepts and techniques are universal.
And there are tons of resources online, too.
Right. You've got interactive tutorials, open source libraries where you can experiment with building your own models. It's incredible how accessible this field has become.
It really is. Anyone with a computer and internet access can start exploring.
Exactly. And there are these fantastic online communities, too. You can connect with other deep learning enthusiasts, share projects, get help, learn from each other.
I love that. So for anyone who might be feeling a little intimidated by the technical stuff, just remember that everyone starts somewhere.
Absolutely. Start with the basics, find what interests you the most, and don't be afraid to just dive in and experiment.
And have fun with it. Deep learning is a powerful tool, but it's also a doorway to so much creativity and exploration.
Couldn't have said it better myself. We hope this deep dive has sparked some curiosity and maybe even inspired you to embark on your own deep learning adventure.
That's it for this episode of The Deep Dive. We hope you enjoyed exploring the fascinating world of deep learning with us.
Keep those brains buzzing, stay curious, and we'll see you next time on The Deep Dive.